Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends. In this video, we will study the data transfer instructions in 8051 microcontroller. So let us start with our topic. In the instruction set of the 8051 microcontroller, there are various instructions, and these instructions are used to perform various types of operations. So depending upon the operation performed by that instruction, they are divided into different categories. So the complete instruction set of the 8051, it is divided into 6 categories. So the complete instruction set, it is divided into 6 categories. First is the data transfer instructions, arithmetic instructions, logical instructions, branch instructions, subroutine instructions and bit manipulation instructions. So depending upon the operation performed by that instruction, they are divided into different categories. So in this video, we are going to study in detail about the data transfer instructions. As the name suggests, data transfer means these instructions, they perform the operation of transferring the data from one location to another location. So the location from which the data is transferred, that is called the source location, and to which place the data is placed, that is called the destination location. So from source, the data is transferred to the destination location. The transfer of data doesn't mean that from the source, if the data is transferred to destination, the data is deleted from the source location. The data will be there at the source, but it is just copied from source to the destination location. Now in this data transfer instruction, we have 3 types of instruction. First is the move instruction. Okay. Second, we have push and pop instructions. And third, we have exchange instruction. So these 3 instructions, they come under the category of data transfer instructions. Let us study them in detail. First instruction was the move instruction. So this instruction move the contents, or we can say copy the contents from the source location to the destination location. Now this source location, it can be any of the registers, like the special function registers it can be, or any of the 8 registers of the register banks. In 8051 we have 4 register banks, and each of the banks, they have 8 registers in it. So it can be any of the 8 registers of the register bank, or it can be any special function register, or it can be accumulator, or it can be a memory location in the internal memory as well as in the external memory. Okay, so the contents from the source, they are copied to the destination. So first type of move instruction we have, it move the contents of a register Rn to accumulator. So this move instruction, it is going to copy the contents of the register Rn. N is from 0 to 7 because each register bank, that is bank 0 to bank number 3. We have 4 banks, registered banks, and each bank is having 8 registers. So from R0 to R7, we will have 8 registers. And how the bank is selected? We have the bank selection bits in the program status word of 8051. So from there we can select the bank. So the registers of that selected bank, that contents will be copied to the accumulator. If we see an example, like we have move A, R2 or move A, R7. So here the register number 2 of that selected bank, the contents will be copied to the accumulator. Here the register number 7 of that selected bank, those contents will be copied to the accumulator. So here R7 and R2, these are the source and accumulator is the destination. Okay. So from source to destination, the contents are copied. Second move instruction we have move the contents of A to Rn. Just reverse of first, that is here R was the register was the source and accumulator is the destination. Now accumulator is the source and register is the destination. Example of this is move R4 comma A or move R1 comma A. So contents of accumulator will be moved or copied into R1 and R4 registers, the registers of that selected bank. Okay. Next we have so in this, the contents of means an immediate 8-bit data will be available in the instruction itself, and that 8-bit data will be copied into a register A or to a register Rn of the register banks or to a memory location using direct or indirect type of addressing. Addressing mode are the modes in which are the ways in which the operand is specified in the instruction. So in the addressing modes we have direct addressing also and indirect addressing also. So let's see the example of this type. So examples of this are like move an immediate 8-bit data. So whenever an immediate data is given in the instruction, we use this hashtag sign. Okay, so this sign is used to represent an immediate 8-bit data. Now this data can be transferred to the register A. So first instruction, this 45 will be stored into the accumulator. In the next instruction we have the destination as the register number 6 of the register bank. So in this R6, 56 will be transferred or copied. Move 30H, it is the example where the memory location is there. So 30H is the memory location. So at that memory location the 44 number that will be copied. Then indirect addressing can also be there. So here we have used the address which is stored in the register number R0. That address, at that address this number will be stored. So suppose that in R0 we have some address like 34H. So that at that address this number E8, it will be stored. Okay. So this type of addressing is called the indirect addressing. Whereas direct addressing, where we have directly written the address in the instruction. So that is the direct addressing. Now move DPTR. DPTR is the data pointer. So data pointer, it is a 16-bit number. So here 16-bit data will be there. So immediate data will be of 16-bit, and that 16-bit data will be stored into the data pointer. So these are the two examples. Okay. So this was the example where an immediate 8-bit data is transferred into the source location. Okay. So next example of move instruction is where the contents of a memory location, they are moved into the accumulator, or the contents of the accumulator are moved to a memory location, and we can use both direct or indirect type of addressing in it. Let's see in some examples of it. So these are the examples where the contents of a memory location, you can see 65H is, it is a memory location. No hashtag sign is written before it. So it will be a memory location. If hashtag is there, it means it will be an 8-bit data. So that's the difference. Don't get confused that what is an 8-bit data and what is a memory location. Before an 8-bit data, you will always get a hashtag sign, and memory location, there is no hashtag sign. So the contents of this memory location, they will be stored into the accumulator, they will be copied. Here indirect addressing is used. In R0 register, we have the address of that memory location. So at that memory location we have the data, so that data will be copied into the accumulator. Similarly here, the contents of accumulator, they are copied into the memory location. Also here, contents of accumulator, they are copied into the memory location whose address is stored in the R1 register. So because here we have this asterisk sign, so this at sign is there. So this sign is used wherever we are using the indirect type of addressing. So we can have both direct and indirect in this type of move instruction. Now next example is where we have to move the contents of a memory location to the register, or the contents of the register to a memory location using only direct addressing. Okay, example of this is move R3, 65H and move 45H into from R2. So contents of memory location 65, they are copied into the R3 register, or the contents of the register R2, they are copied into the 45 memory location. So here direct addressing is used, no indirect addressing is here. Directly the address of the operand is given in the instruction itself. Next we have the move instruction. In this, the contents of a memory location, they are moved to another memory location, and here we can use both direct and indirect addressing. Examples are move 47H, 65H, or we can use move 45h. So first we are directly giving the addresses of the memory location. So data transfer can take place between memory location also. From 65h to 47h the data is copied. Here indirect addressing is used. The address of the memory location is stored in the R0 register. So R0 register is suppose having the address like 55. So at that memory location some content is stored, so that content will be copied into the memory location 45. So all these what we are studying, these are the types of move instructions. Okay, next type of move instruction is now earlier whatever memory locations we are studying, they were in the internal RAM of the 8051 microcontroller. Now the moving of the contents it can take place with the external memory also. So next move instruction is to move the contents of an external memory to the accumulator or the contents of the accumulator to an external memory. Like example we have move A comma at R1. Okay, so this is the type of memory here we are using is the external memory. So move instruction, you can see earlier we have the format for move instruction, the mnemonic is MOV. Now the mnemonic has changed, MOVX. So it is also a type of move instruction where external memory is related. So here the address of the memory location will be in the R1 register. At that memory location we have the data. So that data, that memory location will be in the external memory. So that data will be copied into the accumulator. So here we have the indirect type of addressing. Similarly here we have the data pointer, contents of accumulator are copied into the data pointer. So here the contents from an external memory, they are used. Next move instruction we have to move the contents of a program memory to the accumulator. So examples of this will be here the mnemonic will also be changed. We will have MOVC. So wherever C is used means we are using the program memory or the code memory. So MOVC A. So here we will have a base register. In this base register we will have an absolute value of or the offset address will be stored. So the address which is stored in the accumulator plus the contents of the program counter. So that memory location which is in the program memory, the contents of that memory location will be moved into the accumulator. So for program counter and data pointer, program counter we have the base registers at the as the accumulator only. Okay, so contents of accumulator means that memory location plus the data pointer, it will make it will combine. A will have this at A will have the offset address plus this data pointer and the program counter, they will be added. We will get the physical address of that memory location where the data is stored. That data will be copied into the accumulator. So this complete address, it is denoting the address of a memory location in the program memory. Just see the move instruction, its mnemonic has been changed. We have MOV, MOVX and MOVC. Okay. So these were the move instructions, okay, which are simply copying the contents of the source to the destination. Source can be any of the registers, accumulator, memory location. It can be any special function register also, and destination can also be a memory location, register, accumulator, or a special function registers. Okay. Next instructions under this data transfer instructions category, we were having were push and pop instructions. Now these two instructions, they are related to the stack. Stack, it is a memory location, it is a block of memory location which is used for temporary storage of data. Whenever the microprocessors or microcontrollers, they are dealing with the interrupts, so the interrupt service routine they have to execute. So to store the contents of the program counter and the flag register, they use the stack. So to store any content or any data in the stack, we use the push instruction, and to retrieve the data from the stack, we use the pop instructions. So push is used for storage and pop is used for retrieval. Okay. So if we talk about, suppose this is the stack. Stack is initialized at some memory location through the stack pointer. Stack pointer, it always points at the beginning of the stack, from where the stack is starting, and the storage of data, it takes place after that stack pointer. Stack pointer will be incremented. Suppose a stack pointer is initialized at 08. Okay, and when we want to store some data, so stack pointer will be incremented by 1, it becomes 09, and then the data will be stored. If we want to retrieve, suppose from this memory location 09 we want to retrieve, so first it will be decremented by 1, that is SP minus 1, it will become 08, and then the data will be retrieved. Let's take some example so it will be clear to you. Suppose that we have initialized the stack pointer by 07H. Whenever the 8051 microcontroller, it has reset, the stack pointer is always initialized with this value 07. So we can say that this is the default value. Whenever 8051 is reset, stack pointer will always start from 07. Now first we are moving the data into some register. Okay. So here we have written the 3 instructions for moving the data. We have used the 3 registers R6, R1 and R4. And we are storing some immediate 8-bit data into these registers. In R6 we have 25, in R1 we have stored 12, and in R4 we have stored F3. Okay. Now we want to store the contents of these 3 registers into the stack. So what we are going to write here, we will write push 6, push 1 and push 4. Means push 6 means the R6 register, the 6th register. We need not to write R6 again. If we are writing 6, then only the 8051 will get to know that we are talking about the 6th register of the register bank. So 6th register, that contents, that means 25, that will be stored into the stack pointer. So earlier stack pointer is initialized at 07. So whenever push instruction is written, the stack pointer, it is incremented by 1. So it will become 08. So at this 08 memory location, the R6 register contents, that is 25, will be stored. Again it is incremented by 1, SP plus 1, because now the stack pointer is at 08. It is incremented 09. Next register 1 is stored, that is 12. Again push is there, stack pointer is incremented, it will become 0A, and next R4 register is stored. So this is about the push instruction. The stack pointer is every time incremented by 1 and the contents are stored into the stack. Next, if we are writing here pop 6, pop 4 and pop 1. Sorry, the sequence will be pop 1 and then pop 4, because when the contents are storing, first the contents of 6 register are stored, then first is stored and then fourth is stored. So they will be retrieved in the same sequence. First the 6 will be restored, then 1 and then 4. So now we have this stack pointer is at 0A, so this will be decremented, it will become 09. Okay, and this F3 will be restored. F3 will be stored at the 6th register, that is in the 6th register. Now the content will be F3. Earlier it is 25, but we have retrieved the value as F3, so F3 will be now stored in this register. Again stack pointer is decremented, it will become 08. At 08 we have when it is decremented we were having 12, so 12 will be now stored into the 1 register, so R1 will have 12. Then again it is decremented 07. At 08 we were having 25, so R4 will have 25. So after the execution of pop instruction, the stack pointer is decremented by 1, and in the case of push instruction, every time it is incremented by 1. So these are also the type of data transfer instruction where the data is just copied from one memory location to another memory location. Okay. Next instructions in this data transfer category, we have the exchange instructions. So in exchange instructions, we have the contents of the source and the destination. They are exchanged. They are not deleted. They are only exchanged. Like we have two registers, register A and register B. So A is having suppose 25, B is having 35. So if their contents are exchanged, so now A will have 35 and B will have 25. So exchange instructions, they can occur between two memory locations also, or between two registers also. Now in 8051 microcontroller, this exchange instruction, exchange of contents, it is done only with the accumulator. Okay, so here one of the destination, it will be the accumulator, and source can be a register also, it can be a direct memory also, or it can be an indirect memory also. If we talk about the examples here, so we will have XCH, it is the mnemonic for the exchange instructions. Destination is our accumulator. So if we can have the direct memory, we can have register like R3 register. We can have direct memory location also. And indirect memory location also. Here the source is a register. Here the source is an indirect memory because memory address is stored in the R1 register, and here we are directly writing the address. Okay, so these are the three types of exchange instructions. Also we have in this exchange instructions, we have exchange digit instructions also. Now in this exchange digit instructions, the accumulator, it is an 8-bit register, so it will have the contents from A0 to A7. In this we have A0 to A3 and A4 to A7. 4 bits are there. So this is called the lower nibble. Nibble means 4 bits. A group of 4 bits is called a nibble. So lower nibble, and this is the higher nibble. So in this exchange digit instruction, the lower order nibble, the contents of that lower order will be exchanged with the contents of the internal memory location. Now internal, so means this exchange is taking place with the internal RAM. And this internal RAM is indirectly addressed by a register. Let's take an example. The mnemonic for this exchange digit will be X, C, H, and D is for digit. Okay. Destination will be our accumulator, and the internal RAM, because it is indirectly addressed by a register, so we will use the @ sign, and here we will have the register R1. Okay. Also another example, we can use R0 register also. R1 and R0 are used for addressing the internal RAM. Okay. So here the lower order nibble of the accumulator, it is exchanged with the internal RAM. Okay. So these are the data transfer instructions in the 8051 microcontroller. Three instructions we have. First is the move instruction, second we have push and pop instructions, and third we have the exchange instructions. In move we have different types of move instructions, like between memory to register, register to memory, from accumulator to memory location, and between the memory location also. Okay. Then we have the push and pop instructions, which are related with the stack operations, and third we have the exchange instructions, in which first we have the exchange of contents with the accumulator, and second we have the exchange digit, in which the lower order accumulator is exchanged. Okay, so these are the various types of data transfer instructions in the 8051 microcontroller. So I hope that this topic is clear to you. Thank you.